With this question, we want to write the expression this in the form root a minus root b, where a and b are integers. Okay. Now, the first thing I notice or observe is that 2011 is completely arbitrary. Okay, 2011 is arbitrary. That means it has no particular significance, or it seems not to anyway. Especially in these types of questions where it's the year that the question was released or whatever. The number itself rarely has significance when it's kind of large. So we will treat 2011 as x. So we'll consider the expression y is 1 over the square root of x plus root x squared minus 1. This is an x. Maybe that's not so clear. I'll write that out again. This is okay, this is y is 1 over root x plus root x squared minus 1, where x is 2011. So we wanted to see the structure. Okay, we're not bothered about the individual number to start with. We want to get it in the form that we're seeking, and then we'll plug in 2011 at the end. That's kind of our aim. And so, given that's our aim, we're just looking to try and simplify how this looks, right? If we want to look at the structure, we want to look at this in the simplest form possible. So there are a couple of natural things to do. The first one is the most simple. Is that if we square both sides and reciprocate, then we get that 1 over y squared is just x plus square root of x squared minus 1. Okay, that's kind of a reasonably nice form. Now the other thing to notice, I'll just do this in blue. Wait, maybe blue won't show up so well. I'll do it in red. Another reasonable thing to do is to multiply by root, by 1 over root x minus root x squared minus 1. Now, let me explain why. If you have root x plus root x squared minus 1 multiplied by root x minus root x squared minus 1, then as I've shown in the previous video, this is like a difference of two squares. Okay, so first we recall that root a, kind of power laws if you like, root a, root b equals square root of ab, right? This follows because of adding exponents, of grouping exponents, so a to the half, b to the half, alright, i.e. Is equal to ab to the half, right? So recalling this, we're then going to multiply the inside of this bracket, i.e. AB, and we see this it's a difference of two squares, right? This is of the form A plus B times A minus B, which is a difference of two squares, A squared minus B squared. This structure comes up all the time, so it's really useful. So recalling this, we see that that's equal to, I'll use index powers this time. So this is going to be a squared. So a here is x, so this is x squared. B is root x squared minus 1, because we're minusing it here. So we're going to have minus x squared minus 1 to the half squared. Another bracket around this. Squared, and this is all to the power of a half by applying this law. Well, x squared minus 1 to the half squared, these cancel each other out and become 1. So this is just minus x squared minus 1. So this is x squared minus x squared minus 1 to the half. But this is just 1 to the half, which is 1. Okay, so this seems kind of like a nice thing to multiply by. And if we look back at what we start with, then we want to multiply by the reciprocal of this. Okay, So I'll switch back to yellow to show we're in the kind of main solution again. So that's to say that we have, we want to multiply by 1 over this. So the right hand side is going to become 1, and the left hand side will just write as y divided by this. Okay, so y over root x minus root x squared minus 1 equals 1 by this. Okay, we're just multiplying, maybe I should write it 1 over 1 is 1, right? Because the denominator is just this, if you look here. You see? So we have this fact as well, which means that, again, we'll write this in a nicer form, that y squared is x minus root x squared minus 1. Okay, so we have two nice facts here. We have this one, y squared is x minus root x squared minus 1. Let me just copy them up here. And we have this one, that 1 over y squared is x plus root x squared minus 1. Okay, I'll put them here as for ease of referral. So now the natural thing is to add these, right? To get rid of this square root. Again, we're just looking for a simpler form as possible to see as much structure as we can. So so these together imply that y squared plus 1 over y squared is 2x, adding the right hand side. And this factorizes kind of nicely. So this means that y plus 1 over y squared is 2x minus 2. You can hopefully see that by expanding the bracket. And that y minus 1 over y squared is 2x plus 2. Okay, again, we're always exploiting the structure, right? We know, or you'll get to know that this expansion looks kind of like that, and so it seems like a reasonable thing to do to look at these expressions, right? And now we're looking for y. Y is what we started with, if you remember over here, right? Where x is 2011 is arbitrary, so we use x. And so we're kind of after y in a different form. So the natural thing to do from here is to square root both of these sides, and we need to have a bit of care with this one. So the first one's easy, because we know y is positive, right? We know y from the initial expression. Again, well, we can use the fact that it's 2011 here, maybe. So this denominator is roughly root 2 times 2011, which is quite high. It's definitely bigger than 1. And so y is 1 over something that's bigger than 1, so y is less than 1. Okay, so I'll just say note NB is Latin for, I don't know, something to do with note. So we'll note that y is less than 1, i.e. 1 over y is bigger than y. Okay, so if we want the positive root of this, we're going to need to swap these around. Let me just rub this out, write it again underneath. Okay, so, whoops, I don't want to write that big. So, normal size, yellow. So this implies, well, if we square root the first one, we're only interested in the positive root, and we have that y plus 1 over y is the square root of 2x minus 2, and that y minus 1 over y, but then we have to, we want positive on this side, right, because we're having the positive root. We're here now, looking at this equation. We want to take the root, but this is negative, right, by by this. So we want minus this is equal to 2x plus 2. And so now we want y on the left hand side, so we just subtract these two things. So subtracting gives, okay, so we're going to have, on the right hand side, we're going to have 2x minus 2 minus root 2x plus 2, and on, wait, does that make sense? This is going to be negative at this rate. Sorry, have I written this right? Let me think. So, okay, so we have that the left-hand side, when we subtract, is going to be 2y, right? Because minus minus is a plus, so that's like adding y plus 1 over y with y minus 1 over y, which is 2y. And this is root 2x minus 2 minus root 2x plus 2. I think I've got my plus and minus 2 the wrong way around somehow, because otherwise this is going to be negative. Okay, let's have a look. Where did this go wrong? So this is minus, this seems right. Why is this going wrong? Okay, there should be a minus sign in, sorry, give me a minute. Yeah, okay, I got it. Sorry, this should be the other way around. I should maybe write it down rather than just assert it. So this is plus, this is minus. Okay, so this is plus. Oops. Plus. This is minus. This is a plus. This is a minus. Right, you can just check this from expanding the brackets. I did it wrong. Tried to do it in my head and failed. So this is definitely right. Okay, so this is 2x plus 2 minus root 2x minus 2. And so now we can plug back in that x is 2011. So y is, we want these as integers. So y is, well, 2y is root 4024 minus root 4020, and divide by the 2. 4 factors out of these, so root 4 is 2. So this implies our final solution of y is root 1006 minus root 1005, and we're done.